Here's question 4, and this is where things start to get really interesting. You may not necessarily see this, but we have two triangles that are kind of touching each other right at the very top. And it may be helpful for you to, instead of looking at the triangles together, maybe it helps you to draw them separately, which is what I'm about to do right here for you. So I'm going to use the line tool. Give me some nice straight lines here. Look at that. Perfect. They don't have to be, the best. Like this triangle is okay, but as long as they get the job done. So A, B, C, or sorry, A, B, E, we'll do that one right here. A, B, E. The side between A and B was 27. And the side between B and E was 36. And then we'll do D, B, C right over here. D, B, C. Always a good tool, right? If something doesn't look good right away, you can always like reorient it. And that's a good spatial awareness skill that this unit really does try to teach you, is that you could take a triangle and you could rotate it, you could spin it, you could flip it inside out type of deal. There's a lot of things you have to do with triangles. So, okay, well, we need to figure out, again, which one we're going to use, side, 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 angle, side, or angle, angle. And, I'm jumping ahead of myself here, but I only see, for this first triangle, I see a side here, and I see a side here, and then I see a side here, and I see a side here. I only see two sides. Am I missing something? Is something not there? And actually, there's something that's kind of hidden. You need to understand where it is before you can kind of gain access to it. And it's this idea of vertical angles. What vertical angles are angles that are kind of made through when two lines cross each other, right? Here's a line, and here's a line. There's this beautiful rule where this angle right here, which would be this angle here, is actually congruent to this angle right here. These two have to be the same. They're congruent, which is very, very helpful for us because we could then say that angle B is congruent to angle, that's angle B. This seems like actually like a duh statement, right? Like 2 is equal to 2, 4 is equal to 4, 10 is equal to 10. All these things should be equal to themselves, and the same thing works for angles, right? So let's look at what we have now. We have a side, an angle, and a side, and over here we have a side, an angle, and a side. Okay, well, now it's coming together, right? We know we're going to use side, angle, side. So once again, we know that two angles are congruent. Angle B is congruent to angle B. So let's look at the small sides here. We have this small side of 27 and this small side of 18. So 27 over 18. And then we will look at the large sides. So the large sides, we have 36 from the first triangle. We divide it by the other triangle, which is 24. Okay, well, let's take out our calculator. Let's do 27 over 18. And then was it 36 and 24? 36 divided by 24. All right, both of them are 1.5, so they're the same. That means the ratios of corresponding sides are the same, and there's a congruent angle between them. Remember in the last video I said the angle has to be in between the two sides, just like how it is here. So because these ratios are the same, because if there's a corresponding congruent angle between them, what I could say is triangle ABE is similar, again, that squiggly means similar, to triangle, let's make sure we get the name right. So I want ABE, so I'm going to go DBC by side, angle, side. That'd be my answer.